Example 2.2.8, differentiate the following sets of functions. Part A, y equals u squared plus u and u equals 3x squared. To differentiate this set of functions, we use the second definition. So, we let dy du, that's the derivative of y with respect to u, that's equal to the derivative of u squared plus u, that would be 2u plus 1, and if u equals 3x squared, then du dx, that's the derivative of u with respect to x, is the derivative of 3x squared, and that would be 6x. For the definition, dy dx equals dy du times du dx. That is, the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Let's set that equal. So that's equal to, and so dy du is 2u plus 1, du dx is 6x. We will now substitute back u for 3x squared, and we get that is equal to 2 times, and where u was, we put in 3x squared, plus 1, we still have times 6x. That is equal to 2 times 3x squared is 6x squared, plus 1. And that is still times the 6x, so we'll distribute the 6x through, and finally we get that dy dx is equal to 36x cubed plus 6x. For this problem, let's note that substituting first gives, so for y equals where u squared was, we put in 3x squared, squared plus u, we put in 3x squared. That's equal to 3x squared squared is 9x to the fourth. We still have plus 3x squared. When we take the derivative, y prime is equal to, bring down the 4, so 9 times 4 is 36. 36x to the power of 4 minus 1 is 3, plus the derivative of 3 times x squared, so 3 times 2 is 6, x. You might note that this was a little bit easier and more straightforward way to solve. Example, Part B. Y equals the square root of the quantity 7 minus 3u and u equals x squared minus 9. We'll use the second definition that's expressed with Leibniz notation. That is, dy dx is equal to the product of dy du times du dx. Let's rewrite y. Y is expressed as the square root of 7 minus 3u. In order to use the power rule, we need it with a power, so let's rewrite this radical as 7 minus 3u to the power of 1/2. Then the derivative of y, dy, with respect to u, du is equal to, and we'll apply the chain rule. Bring the 1/2 down, that's the power, make it the coefficient. The inside function 7 minus 3u stays put. 1/2 minus 1 is minus 1/2 for the power, and the derivative of the inside function, that's 7 minus 3u, that derivative is, well, the derivative of 7 is 0, negative 3u would just be negative 3. Let's clean this up a little bit and write it as negative 3/2 times the quantity 7 minus 3u to the power of negative 1/2. Now, we are given that u is equal to x squared minus 9, so the derivative of u with respect to x is the derivative of x squared minus 9, which is 2x. Let's put it together. dy du is negative 3/2 times, and let's write it with no negative exponent, so 1 over 7 minus 3u. That puts the makes the negative into a positive. We put it in the denominator, and instead of writing 1/2, we'll use the radical symbol. Then we need to multiply that by the derivative of the du dx, which is 2x. Now the problem is we need our answers in the form of y and x only. We have a u, so we need to substitute the u into the first part of the equation, and now we will have dy dx is equal to -3/2 1 divided by the square root of 7 minus 3 times the quantity x squared minus 9 times 2x. And then we have one more simplification to do. That is, we can cancel the 2's. So I'll try to write real small. dy dx is equal to, we'll have a -3x in the numerator divided by the square root of, let's simplify. Distributing the -3, I get -3x squared. -3 times -9 is positive 27, and that 27 plus the existing 7 would make it a positive 34. Example 2.2.9, find the equation of the tangent line to the graph of y equals the quantity 2x minus 3 to the power of 4 at the point 1, 1. Also, determine where the tangent line is horizontal. Let's see, to get the equation of a line, you need 3 pieces of information. You need a point, and the problem already gives it. It's the ordered pair 1, 1. We need the slope. And in order to get the slope of a line, we need to find the derivative and evaluate it at the specified x value. So we need y prime at 1. So let's find y prime. We'll use the chain rule. That means we bring the power down and write it as the coefficient. And we subtract 1 from the power, so 4 minus 1 is 3. The inside function stays put. And then you take the derivative of the inside function and multiply it through. So the derivative of 2x minus 3 is 2. We can simplify this to 4 times 2 is 8. And then we still have 2x minus 3 to the power of 3. We need to compute the derivative at 1. So let's evaluate. That is, we'll do y prime at 1, which will be 8 times the quantity 2 times 1 minus 3 to the power of 3. That's 8 times 2 minus 3 is -1 cubed, and if a negative is raised to an odd number, it remains negative, so the slope, m, is -8. Now we'll use the equation of a line. We got the point, we got the slope. Now for the equation, we'll do y minus y1 equals m times x minus x1. Let's fill in the parts. Y minus 1 equals -8, x minus 1. And we can clean this up just a little bit. We can write y equals -8x distributing. So -8 times x is -8x. -8 times -1 is positive 8. And then add 1 to both sides. So we get 9. The equation of the tangent line is y equals -8x plus 9. Oh, continuing with the problem, we have to determine where the tangent line is horizontal. So tangent line is horizontal. That means find the derivative and set it equal to 0 and solve for your x. Well, we found the derivative in the previous part of the problem, and we got that y prime is equal to 8 times 2x minus 3 to the power of 3. We need to set this equal to 0. So we've got 0 equals 8 times 2x minus 3 cubed. Let's divide by 8 on both sides. Then we get 0 equals 2x minus 3 cubed. Now we need to take the cube root of both sides. So let's see, cube root of 0 is 0, and we get the linear equation 2x minus 3 left. Now we can solve for the x. That is, we got minus 2x equals negative 3. X equals positive 3 halves. So at 3 halves, f of 3 halves, okay, we have a tangent line that is horizontal to this graph. Example 2.2.10. Consider the function g of x equals f of x raised to the power of 7. If f of 4 equals 2 and f prime of 4 equals negative 1, then find g prime of 4. So for this problem, we need to find g prime before evaluating. So g prime of x is equal to, we bring the power into the front. The inside function stays as is inside the function. 7 minus 1 is 6. Then we need to multiply it by the derivative of the inside function, which we'll write as f prime of x. So now if we want g prime at 4, we want 7 times the function f evaluated at 4, that raised to the 6th, times the derivative evaluated at 4. Let's make the substitutions. 7 times f of 4 is given as 2 to the 6th times f prime at 4 is negative 1. So let's multiply. We got 7 times 2 to the 6th times negative 1. That'll be negative 448.